Hello, welcome to this lesson of our study of partial derivatives. Okay, so in this lesson we just go through what we mean by the directional derivatives. Okay, so if you have not subscribed to the channel, kindly subscribe. Okay, all right, let's start. So let f of xy be equal to this function here. Okay, square root of the expression 81 minus x squared minus y squared. Okay, and find the rate of change of f as we move from the point P, which is 1 comma 4, in the direction toward the point this. Okay, so here we want to know the change of f as we move from one point to another. Okay, in some particular direction. Okay, so with that direction, that's what we call the directional derivatives. Okay, so you are just finding the change in f in that direction. Okay, so this is how the directional derivative is brought about. Okay, so the formula for it is this. This is being represented as a du, okay, f slash p equals del f slash p dot u cap. Okay, I'll explain all the terms. Okay, so this is a symbolic representation of the directional derivatives, and this is how we simplify it. Okay, now with the del is an operator. Here we are being given a function in two variables. Okay, so the del, I will state it in two variables or in two dimensions, is given as this del x I plus del yj. Okay, so this in two dimensions, this is how it is being defined. So in three dimensions, you mean we'll have del z of times k. Okay, this is what the del means. So the del f means that when you put f here, meaning multiply this to f, it means that wherever I see something, I just have to put f here and here. So it becomes del f del xi plus del f del yj. In other words, the derivatives of f in its respective components. Okay, the x and y. Then just attach I and j to it. Okay, so slash the p means simplify that at a particular point p. And the u cap here, this u is actually the direction in which we are talking about, or the direction in which we are taking the change or the derivative in. Okay, but we don't need the u, because when you put u there just like that, there can be plenty vectors of which will be parallel to u, and that will be in the same direction as u, and the magnitude may be changing. But here we want to get a magnitude that a vector that has a magnitude of 1, that it can't change no matter what you do. The magnitude is the same, and so that is why we will need the u cap. Okay, so the u is just the direction in which we are having our derivative in. Okay, so here let's fish out our f of xy, and it's equal to f of xy is equal to square root of the expression 81. Okay, 81 minus s squared minus y squared as our f of xy. And our u, let's go and read the question again. It said move from the point P. So the point P where we would simplify del f is just this P. Okay, so it's given in the question, but then this P, this is what we'll use for the P. Now the question is, what will be our u? So P is in the direction towards the point Q. So okay, we have to find a vector in that direction, PQ. So we have to find vector PQ. Okay, so from vectors and mechanics, this is simply OQ minus OP. Okay, and this will be equal to OQ is simply 4,8. Okay, so have 4i plus 8j minus 1,4, so I have I plus 4j, and this will simply give me 3i. Okay, this will give me 3i plus 4j, and we said we need, this will be our u. Okay, and we'll need our u cap. Actually, we'll need u cap, so quickly our u cap will be Very simple. The unit vector along this, so it's very simple like that. It's 3 over 5 I plus 4 over 5 j. I mean, find the unit vector of this, and I know you know how to find the unit vector. Okay, so that is our u cap. Now that we need to do is find del f. Okay, and we said is what del f del x I plus del f del y j. This is because it is in two dimension. Okay, so you have to find our del f del x, given f of xy being equal to, now I want to write it as a bracket form. Okay, so 81 minus s squared minus y squared all to the half, so that when I differentiate I'll see clearly. Okay, so del f del x is the same as fx. Okay, but let's use the del f del x here, and this is equal to half into 2x into 81 minus s squared minus y squared all to the negative half. I hope you can see what I'm doing here, and this will actually give us x over the square root of 81 minus s squared minus y squared. Okay, and del f del y will also give us something similar, which will be y over the square root of 81 minus s squared minus y squared. With this two you can check. Okay, I hope by now you know how to do all derivatives. Okay, minus y squared. Now we need to simplify this at the point P, and P is what? P is equal to 1,4. Okay, so del f simplified at the point P, which is 1,4, would then be equal to, you put 1,4 into these 2 points. Okay, del f del x is this. Okay, so you put 1 for x and 4 for y, and del f del y is this, so you put the same thing. You simplify whatever you get, I for the del f del x part. Okay, so when you put it in the del f del x, you get negative what? You get negative 1 over 8 I. Okay, so the del f del x part, when you simplify, you get negative 1 over 8. Then with this you get negative 1 over 2 j. So our directional derivative that we are looking for here is the dot product of this and our u cap, and u cap is what? This. Okay, so our u cap is equal to what is our u cap? 3 on 5 I. Okay, plus 4 on 5 j. So the dot product of these two, when you dot these two, that will be our final answer. And when you dot them, it's like this, negative 1 over 8 I minus 1 over 2 j dot 3 on 5 I plus 4 on 5 j. Okay, dot them, and this will give us negative 19 over 40. Okay, so the directional derivative, that is the rate of change. The question is, you are supposed to find the rate of change of f as we move from so the rate of change as we move from that point towards the direction that is this. So that's simple like that. Okay, let's look at another one. Find the derivative of the function f of xy equals x e to the y plus cos xy at the point 2, 0 in the direction of v equals that. So here they've given us a direction, but is the direction a unit vector? No. So all that we need to do is find the unit vector along that direction. Okay, so we have to find v is given here is v. So all that we have to do is, what we want to find here, the directional derivative is given by del f simplified at the point 2, 0, because the point is given as 2, 0 dot v cap. Okay, and you know del f is given by what? Del f is given by del f del x I. Okay, so in 3 dimensions, you should know that in 3 dimensions there will be a j component, a k component. Okay, del f del y j. Okay, so all that we need to find is find out f of xy, find out del f del x and del f del y. Okay, so here f of xy is giving us where is that? F of xy is giving us x e to the y power plus the plus, let me see, plus cos xy. Okay, so here the f del x is simply equal to e to the y power minus y cos xy, sorry. Okay, and our del f del y is equal to x e to the y power minus s cos xy. Okay, I hope you can see this. So all that we need to do is simplify these at the point 2, 0. Okay, so at 2, 0, when you put 2 and 0 in place of x and y, we'll have this to be equal to, so let me write at 2, 0, we have the del f simplified at that point is 1. Here will be 1. Okay, I think that will be it, because it will be 2 to the power 0, e to the power 0, which is 1 minus 0. Okay, so that will be 1, and here will be 2 times e to the power 0, which will be 2 times e to the power 0. Okay, so it will be 2, then cos minus 2 times, is it 2 times cos 0? Let's see. When we put 2 inside, sorry. This is sine. This is supposed to be sine, right? Okay, I'm really sorry about that. It's supposed to be sine of that. Okay, so it will be 2 minus 0 like that. That is why I was having problems with it. Okay, so this will give me 2. It means that my del f simplified at a point 1, is it 1 4? No, it's 2, 0 is equal to I plus 2j. So our v cap will simply be equal to the unit vector along the v, and v was given as what? This is our v, which is 3i minus 4j. Okay, so it will be 3 over 5 I minus 4 over 5 j. That is the unit vector along. I hope you know how to find the unit vector. Just find the magnitude of the vector, then divide every term of the vector by that magnitude. Okay, alright, so now the dot product of these two is our directional derivatives. Okay, so our final answer is I plus 2j dot 3 over 5 I minus 4 over 5 j. Okay, and this will be equal to 3 over 5 minus 8 over 5, which will be negative 1. Okay, so that is our solution. I hope this is very cool. Alright, let's continue. Find the gradient of f of xy, which is equal to ln of x squared plus y squared at a point that, okay, so here there is no directional derivative, you just find the gradient at that point. And the gradient of the function is given by del f. Okay, the solution that I want to find is del f, but then we said we should simplify it as what? 1, 1. So the gradient is actually del f, but then when you simplify, that is what we are saying, that we're supposed to find it at that point. So after finding the gradient, you simplify it. Okay, the del function actually gives you a vector function at the end of your calculation. Okay, it will produce a vector function. So del f, or the grad, the gradient is, the del is the same as the grad. Okay, grad of f. All right, I hope you understand. All right, so del f is equal to del f del x I plus del f del yj. Okay, if you remember, we know that f of xy is equal to the length of the expression x squared plus y squared. Okay, now del x is simply 2x over x squared plus y squared, and then del y is also equal to 2y over x squared plus y squared. Okay, so at the point 1 1, what will be del x? Del x, which is equal to 2x over x squared plus y squared at 1 1 will be equal to 2 over 2, which is equal to 1. Okay, and then del y is equal to 2y over x squared plus y squared, and at 1 1 this is also equal to 2 over 2, which is equal to 1. So the gradient at the point, okay, so the gradient at the point is given by I plus j, okay, or you can see 1 comma 1, because this gave you 1, this also gave you 1, so that is what I want to find. Okay, the gradient at that point is just I plus j, or 1 comma 1. Alright, so thank you, and don't forget to subscribe to my channel to support the channel. Okay, see you next time.